In this next example, we're going to look at the cross-section of a building constructed inside a parabolic framework. This question has come up in an exam paper before, and it's worth looking at again. So given that PQ is 2x meters long, show that the shaded area here is equal to 6x minus 2x cubed square meters. So let's look at step 1. The first thing is really what we need is the breadth here. We've got a length of 2x. If we can get the breadth, we can multiply these two things to get that function there, 6x minus 2x cubed. So if we look at from here to here on the diagram, we know that PQ is 2x. From here to here is just x. Now our task is to try and work out how high the rectangle is. Now if I thought the y-axis, or if I imagined the y-axis was coming down here, then that would be a 0 here. And if I looked at coordinates going the long way, if I think of this as a coordinate grid, I'd have 1, 2, 3 and so on. Now to work out a point on the parabola, if I knew what x was, say for example 1 in this case, if I substituted it into the equation of the parabola, that would tell me the y value on the parabola, i.e. how high up we were. So say for example x was 1 and I substituted it up in here. So y would equal 3 take away 1 squared, that would give us 2. So this coordinate would be 1 along and 2 up, that would give us the height. Say for example that x was a half. If I substituted a half into here, we would get 3 take away a half squared. So a half squared would be a quarter. So 3 take away a quarter is 2 3/4. So that would be a half along and 2 3/4 up. So that would give me the height by substituting these values into the function. But I have x along, so really what I need to substitute in is x itself. So to get how high it is would be 3 take away x squared, and that's exactly what it is. 3 take away x squared. Now for the area of this, I multiply length by breadth. So 2x times 3 minus x squared. 2x times 3 is 6x, and 2x times x squared is 2x cubed. Looking at the question again, we were to show that the shaded area was 6x minus 2x cubed. We've done that here. So find the maximum cross-sectional area of the building. This is another stationary points part of the question. You're hopefully looking for a maximum turning point if you've done it correctly. So take your function. We have to differentiate it, so that will go to 6 and that will go to 6x squared. For our maximum values, a dashed x equals 0. So let this equal 0. Factorise this side, so you can see a common factor of 6 comes out of this. 6 times 1 makes 6, and 6 times x squared minus 6x squared. And to make the bracket equal to 0, x would need to be 1, because 1 take away 1 squared is equal to 0, or negative 1. But since we're talking about values that are lengths of rectangles, we would never have a negative value. You would never get a negative length. So you can only use positive values here, so x would need to be 1. So in our nature table, x is 1. Look at a wee bit before, at 0, a wee bit after at 2. So at the stationary point, we have no gradient. If we substitute 0 into the derivative, we'll get 6 take away 0, that's positive. If we substitute 2 into the derivative, we'll get 6 take away 6 times 2 squared, that's going to come out as negative. So we have a maximum occurring at x equals 1. Now the question says find the maximum cross-sectional area of the building. So here is our function for the area, and we've worked out the maximum occurs when x is 1. So substitute 1 in here and here. So 6 times 1 take away 2 times 1 cubed comes out to be 4 meters squared.